Thank you, and good afternoon on my behalf as well. I'm Hannu Karvonen from VTT, and I'm here with Professor Moncef Gabbouj from TUT. And in this presentation, we will first start about this Research Alliance for Autonomous Systems especially, and then we continue to the more specific approaches for AI.
Keep the microphone close.
Right. Okay, so what is this RAS Alliance all about? I would not say that it's focusing on extremely autonomous systems, as Petri said, but rather at the moment we are looking at semi-autonomous, intelligent, and remotely operated systems. For example, in different contexts, like you have cars or ships or mobile machines, and these autonomous systems enable a lot of things, you know, like more efficiency or even safer operations and so on. And we have been looking at these different domains, and there's so much potential for cross-learning because there are similar issues, there are similar technologies, there's a lot of best practices that can be benchmarked through domains. So that's why in RAS we have this multi-domain approach. And we are not focusing on any specific environment particularly, but looking at them from a multi-domain perspective. And what we want to provide is this one-stop shop access to top research in autonomous systems with this cross-industry focus, like I said. And we aim to provide this through these different research task forces that are organized around these main focus areas that we have defined voluntarily. It's actually based these areas on quite deep thematic work that we have done related to autonomous systems, looking at what are the relevant topics that need to be tackled. So basically we have their ethical and acceptability, legal aspects, obviously AI and big data analytics. There's business level, operational level, and all this technical stuff like situation awareness, sensors and connectivity, cybersecurity, and remote operations. And basically, some of these are more overarching themes, and some are more like specific, focusing on specific topics. But I would say that in our context, AI is more like an overarching theme. So looking at, for example, how AI can be used in business or in operations and so on. But in general, we see that autonomous systems are like the key application areas for AI. Okay, so currently we have around 100 researchers on board from these different organizations you can see here. Basically, if you are interested in joining as a researcher, just contact me. I have my details at the end of this presentation. Then we have a few companies that we have discussed with and got some good support and feedback from to the research teams and all this collaboration that we have. And we also aim for international collaboration, so we have quite a bunch of international organizations that are involved, especially from the maritime side, but also focusing on road traffic, drones, work machines. Then finally, here's in a nutshell what we offer. So this is an access point to the professionals in our national and international network of top experts in autonomous systems research. Then we provide steering for the long-term autonomous systems research in Finland and support the policy briefing on that national level. And then also we support autonomous systems testbed development and activity. And basically, like I said, we want to provide a one-stop shop service approach for the applied research needs of the industry. And Moncef will then continue on the AI topic, and you're actually leading our task force related to that.
Okay. Thank you, Hannu. Thank you, Petri. AI coin has two sides. One side is represented by most of you in the company side, the applications, the UI. That's what you do in the AI. The other side of the coin is the engine, the thing that enables you to do AI, the machine learning engine. And that's what we're going to talk about today, very, very briefly, how to enable this AI application so that you can do your work and you can make business and you can make money. So if you need help in enabling your technology, perhaps you can call on us if we can be of any help. In Tampere, AI is a strategic theme at the universities, also at lots of companies. Recently, 6 million euros been given by the Academy of Finland for Tampere 3, that's University of Tampere, and TUT to build this, what we call the Intelligent Society platform, where AI plays a very, very important role. Also been leading this data to decision research community for quite some time. And what we do there is basically coming from our background in the area of signal processing. That is, when you talk about large data, big data, large-scale data, you have lots of sensors data, many large-scale and also heterogeneous that you need to somehow process before you get to any decision-making application. And this layer takes care of the signal processing layer, where you have all the representation, the augmentation, the noise filtering, data ingestion, and so on and so forth. The second layer is where many of you tell about, that's the learning layer, that's the machine learning layer. That's the core enabling technology for AI. Without this layer, there will not be any AI. But I also make a claim that without this signal processing layer, there won't be much AI from sensors. So this is very important. These two layers is what a lot of us at the university, at the research center, at VTT, focus on and are keen on, that we have the knowledge, we have the expertise that we can take up these types of signals all the way up to the final layer. And this is where you come into play. That's where your applications and services in AI come into play here. So we sort of pull the data up all the way to your applications. And if you happen to be dealing with a physical system or statistical model, then the physics-based and the model-based is taken into account in all of the layers that we deal with. So we do that. And if, for instance, if we talk about the learning layer, then we can use something called hybrid learning. So we learn from the data and also from the model. We may modify the model so that the learning process could also happen at the same time. Now, you can't do any learning, you can't do any machine learning or AI without optimization. We started this optimization work many, many, many years ago. We built our own optimization algorithms. These are genetic-based algorithms, which allow us to do all the sort of things that people used to do in the past, but much better. This is an example of feature engineering. So we could do feature synthesis based on optimized features. We could also embed this optimization algorithm into evolving neural networks, which are not necessarily a static network. These are the things that are inside the engine of many of you, of your services and applications, but they're not static. They are dynamic. They are changing their behavior. How they change their behavior? Through an optimization algorithm and the backbone. It's, again, an enabler. Okay, not so much time left. We can put all these algorithms into certain systems that we can make them work. We can make them do something for you. And the last example I'm going to share with you is this one here, because this is very, I think, interesting. This last one here. Yes. So all of you are healthy people. So you can be assured to know that there are people in this country, in this world, who are capable of detecting the first minute, the first instant, the first second, your heart starting beating badly or abnormally, even if you have been healthy all the time. Healthy people, at a certain point in time, their hearts start beating bad. We are able to detect it through what? Through building signal processing systems to detect that with machine learning. And we published this work in Scientific Report very recently. That's, I think, all the time I'm allowed to have here. So thank you for your attention, and be happy to answer questions later.